Hi, hello everybody. So this is the video dealing with section 4.4, trigonometric functions, and this is the second part where we're going to be talking about reference angles and how we can use reference angles to evaluate um, the functions of other angles in addition to the ones that we're supposed to know. Okay, so first of all, the concept of a reference angle is, as you see here in the picture. A reference angle is going to be an acute angle. This is an angle less than 90 degrees that is formed by the terminal side of your angle and the x-axis. Okay, so if I am on the first quadrant, by definition, uh, the angle theta is already less than 90 degrees. So any angle in the first quadrant is already its own reference angle. Okay, so that's why you see here the pictures from your textbook. You only have a new reference angle on the second quadrant, or the third quadrant, or the fourth. Okay, so if your angle is in the second quadrant, the reference angle is this angle right here. The angle formed between the terminal side and the x-axis. If it's on the third quadrant, here is your reference angle. Angle formed with the terminal side and the x-axis. If it's in the fourth quadrant, here's your reference angle, terminal side, and the x-axis. Okay, so the reference angle, it's important that you understand, it's always an angle less than 90 degrees. Now, using the reference angle, we can calculate a lot more, or we can evaluate a lot more functions of other angles in addition to the one that we're supposed to know. Okay, but before we do that, we're going to do a couple of examples about finding the reference angle of something in degrees and then something in radians. Now, your book is somewhat incorrect because it's giving you this angle, but it's not telling that this is in radians. So we have to let you know that this is in radians, okay? Otherwise, we don't know. Okay, so we'll do first the two in degrees, and then we'll do the two in radians. So 345 degrees. So how do we find the reference angle? So it may be a good idea to draw the angle, okay, if you're not quite sure. So 345, as you know, it is in the fourth quadrant. So here's your 345 degrees. And the reference angle, according to this picture up here, is this angle. We call it theta prime. So theta prime would be the angle formed with the x-axis, 360 minus the 345, or 15 degrees. Now, just keep in mind, the reference angle is always positive, okay? Reference angle is always positive. So, negative 135. Let's take a look at the other angle now. Just erase all of that. Negative 135. So, obviously, I am going now in this direction, and negative 135 is here somewhere. Okay, negative 135. Now, I know that the reference angle is this, and this is 180, okay, or negative 180. So the reference angle would be 180 minus the 135, okay, with the negative sign, with the negative sign. So 180 minus 35, what is that, 45 degrees? Now, normally I am going that way, so the angle would be negative, but reference angle, positive angle, 35 degrees. I'm sorry, 45 degrees. Okay. Always looking in terms of positive angles. Now, how about the radians? Now you can do it a couple ways. Okay, these a little bit more complicated because you can say, well, professor, I really don't want to work with pi radians, so can I convert it to degrees? Yeah, you can convert it to degrees, but there's not really a need, and especially if you're giving something like 2.5, then converting it to degrees, it's a little, you know, unpleasant. But we can work with pi radians. Okay, so this is radians. So 5 pi over 6 is a little smaller than 6 pi over 6, right? But 6 pi over 6 is exactly pi. So 5 pi over 6 is here somewhere. This 5 pi over 6. And here is your reference angle. So here's 6 pi over 6, which I know is pi. Okay. So my reference angle would be 6 pi over 6 minus 5 pi over 6 or pi over 6. Okay, so we always need to know where the angle is located. Is it in the first quadrant, second quadrant, third, or fourth? All right, so 5 pi over 6 subtracted from 6 pi over 6, pi over 6. And the last case, this case is a little unusual because we really don't like to work with pi radians and not including the actual pi. Now, so what we need to know is this. Okay, this location here, this angle here is pi radians, but pi is approximately 3.14. So 2.5 is here somewhere. So your reference angle is here. So it's going to be pi minus 2.5. And then we can do this on the calculator. 3.14 minus 2.5. This is all in 0.64 pi radians, right? So your reference angle is 0.64 radians. So we know how to find the reference angle anywhere. All right. And obviously, if we had given you, here's an angle that is 52 degrees, because it's in the first quadrant, obviously the reference angle is 52 degrees. Okay. But so then we know how to find a reference angle in the first, second, third, and fourth quadrant. All right. So it should not be a problem for us. So reference angle is always an angle less than 90 degrees. Form with the terminal side and the x-axis, terminal side of your angle and the x-axis. Now, let's see when the reference angle is a little higher than, 1 full revolution. All right, so for example, 580. And we'll do these two, and I'll leave this one as an exercise. It's not a big deal. So 580. Okay. So 360 is 1 full revolution. And I go a little more. So 580 minus 360. I have 220 degrees, which is here somewhere. So I go one full revolution, and then I stop here. So my reference angle is this. Okay. So it's 220 degrees minus the 180, which is 40 degrees. So reference angle, 40 degrees. All right, how about 8 pi over 3? We'll do 8 pi over 3. Again, 8 pi over 3, it's a little bigger than 6 pi over 3. And what is 6 pi over 3? 6 pi over 3 is 2 pi. Now, this is one revolution on the circle. So we have to know this. We have to know that 2 pi is one full revolution and pi is half a revolution. Right? So here's pi and here's 2 pi. So we can evaluate these angles. I'm sorry, these angles in multiples of pi or 2 pi. So 8 pi over 3 is here somewhere, maybe, right? It's certainly one full revolution, so I can do this. 8 pi over 3 minus 6 pi over 3, because this is two full revolutions. So what do I get? I get 2 pi over 3. All I have to find now is where is 2 pi over 3. Now, 2 pi over 3 is a little less than 3 pi over 3, which is pi, right? So it's in the second quadrant. So here is my 2 pi over 3. Now, you may say the following thing, Professor, this is stupid. Why don't we just convert this to degrees and then find the angle and then do the exact same thing as we did for A? Yes, you can do that. You can absolutely do that. All right. This is my reference angle, which is 3 pi over 3 minus 2 pi over 3, which is obviously pi over 3. Now, obviously, if you convert this to degrees, this is 180 over 3, 60 degrees. And this is what you would find if you convert that to degrees and remove the full revolutions and then find the reference angle. Okay? Now, I have a more interesting problem right here. So I'm going to leave you the 13 pi over 6 as an exercise because as you can see here, this is a little over, right? 12 pi over 6. 12 pi over 6 is 2 pi. And then you can do the same thing as we did over here and here. Now let's find the reference angle for this. This is more interesting. Okay? Because these values on A, B, and C are just too small for it to be any challenging to us. So let's take a look at 3,350. How do we do that? How do we find the reference angle? Well, I have to first find out how many revolutions around the circle this thing is going. So how do I do that? I'm going to do 3,350 divided by 360. And I'm going to use the calculator for that, obviously. So 3,350 divided by 360 degrees because 360 degrees is one full revolution. So I have 9. So this is 9 full revolutions plus something extra. I'm interested in the extra. All right, so now how do I find the extra? This is what you're going to do. You're going to do 3,350 minus 9 times the full revolutions. Okay, and this is going to give me the extra. So 9 times 360, and this is going to be subtracted from 3,350, which is 110 degrees. Now, this is the extra from the 9 revolutions. So here I am, I go 9 times, and then my last lap I stop right here, 110. So you can see that the reference angle is again here. And I am going to do on the second quadrant, 180 minus 110, which is 70 degrees. Okay, so you can do this for every angle that is, for example, gigantic like this. You find the number of full revolutions, and then you find the leftover that did not complete a full revolution. And then wherever the quadrant is, first, second, third, or fourth, you find the reference angle. So these are the basic questions on reference angles. Now, what we really want to do is these questions here. And in order to make the video a little bit shorter, I will do maybe just these two questions. And you can do this for practice, but it's the same thing. And find not only the reference angle, but the value of the function at that particular location, which may require a reference angle. So sine 135. So 135 is certainly not an angle that I do know, but maybe there's a reference angle here that I know. So 135 again is in the second quadrant. And the reference angle here is 180 minus 135, which is 45. So sine of 135 is equal to sine of 45 degrees. Okay, now sine of 45 degrees is one of the angles that I have to know. All right, so we remember seeing this, and this is one of the angles that we have to know. Now, what is that angle? You can check with the calculator, but we cannot use, for example, if you do this on the calculator, right? 45 sine, you're going to get this value, 0.7. Yeah, we cannot use this value. So the questions will always say this. Exact value. Okay, radical 2 over 2. So this we must know. So using reference angles, we do not know sine of 135, but we know that this is equal to that. And I'm going to prove it to you right now because I'm going to do it again, and I am going to find 135. So first, 45 sine 0.7, and I'm going to do 135 sine, and as soon as I click sine, this thing better be the 0.7, the same as sine 45, otherwise I made a mistake. So there you go, 0.7. It's the same value, radical 2 over 2. Okay, so this is how we do it. Now, cosine, let's do cosine, or I guess I said cotangent. So let's do cotangent. Okay. Now, I know that cotangent is 1 over tangent of negative pi over 3. All right. Now, pi over 3 is negative, right? It's in the fourth quadrant. So this is the reference angle. And if it's negative pi over 3, the reference angle is pi over 3. But you got to be real careful here. Okay. Tangent of negative pi over 3 is, the tangent here is negative. So this is minus tangent of pi over 3. Is whatever this value is multiplied by a negative 1. Okay, so this is important. So we have to know that tangent in the fourth quadrant is negative. So in the first case here that we saw that sine of 135 was equal to sine of 45, in this case, cotangent of negative pi over 3 is equal to minus 1 over tangent of negative pi over 3. So you must know this, okay? You must know that tangent on the fourth quadrant is negative. All right, so tangent of, so I know there's going to be a minus here. So 1 over, and if you want to do it, sine pi over 3, cosine pi over 3, if you want to do it that way. So what is sine? So this is, if you wanted to do it in degrees, right? This is sine of 60 degrees, radical 3 over 2. And cosine of 60 degrees is 1/2. So this is radical 3 over 1, or minus 1 over radical 3. I have to rationalize this. So this is times radical 3 times radical 3. So this is minus radical 3 over 3. All right. And we can check. And we can check with the calculator. Let's check with the calculator. And we wanted to go directly to, remember the pi over 3 is 60 degrees, so negative 60. So this is, I'm going to do tangent. I'm going to do this thing right here. I'm going to erase the rest. All right, so this is the answer that we got. Let's not forget this. And I am going to do this on the calculator. So I'm going to do tangent of pi over 3, which is tangent of 60. So 60 degrees tangent. Here's my 1.73. Obviously, there's going to be a negative. Okay, so 1 over that, right? Because it's 1 over minus. So 1 over 1.73, or the reciprocal. Is there a reciprocal here? Yes, there is. So here's my 0.577. And let's do the negative pi over 3 over 3. So 3, whereas this is 0.5. So this is square root of 3 divided by 3 with a negative. So yeah, that's the correct answer, 0.577. All right, so this is good. So we're doing good. This is our answer. We're correct. Okay, and you can do the cosine yourself so that we don't spend whole lot of time on that. Uh, Not too difficult. And let's take a look at the last problem, which is pretty much the same thing using reference angles. So we can do one more exercise. So tangent and secant, well, let's do both. So again, you can do it a couple ways. You can convert this to degrees and then go from there, or you can do it in pi radians. Okay, it's perfectly fine. Do whichever way you want to do it. So I am going to do it in pi radians. Okay. So this is 14 pi over 3. Now, so this is what we can do. We can divide 14 by 3. This is certainly less than 15 pi over 3, right? We can see that. Now, why am I using 15 pi over 3, right? I want to use something that has the same denominator and something a little bigger than that because we need to find the reference angle. Now, 15 pi over 3, if I divide it, is 5 pi. Okay, so my angle, so the 15 pi over 3 is here, right? 15 pi over 3 because it's 5 pi. Now, this location is pi, this location is 2 pi, and if I go another revolution, I'm back here again at 3 pi, and then 4 pi, and then 5 pi. So your 14 pi over 3, I don't need to know what it is, but I know it's here somewhere. It ends up right here. however many revolutions, I am not interested. All I'm interested at is that this is 14 pi over 3 on the second quadrant. And on my x-axis, I have 15 pi over 3. And this is my, again, reference angle. So again, very easy. 15 pi over 3 minus 14 pi over 3 pi over 3. Again, all right. This is tangent now. Now, so tangent of 14 pi over 3 is equal to tangent of pi over 3, but you have to know that on the second quadrant, tangent is negative. You must know that. Have to know that. Professor, I'm never going to remember this. That's okay. If you don't remember, this is what you can do. You get an angle in the second quadrant. What's an angle in the second quadrant? 100 degrees. Let's find what is tangent of 100 degrees. We're not interested in the numerical value. We're interested in the sign. So 100 tangent. And as soon as I click tangent, you are looking for a negative value. There you go. Negative 5.67. That's how you know if the angle or the trig function you're looking for is positive or negative. You don't have to know. You have the calculator to guide you. All I need from this is it's negative, and then you must put this minus here. And then all I have to evaluate is tangent of pi over 3. We already done this before, right? So this is 60 degrees. So this is negative sine of 60 degrees over cosine of 60 degrees. So this is your radical 3 over 2, 1/2 with the minus radical 3. Okay, let's do secant, which is the last one. Secant negative. If you wanted to, you could do, in fact, maybe let's do it that way. Instead of doing it, with pi radians, let's convert this 17 pi over 4 to degrees. Now, I know that I have to do 180 over pi. So the pi's will cancel, and I have 17 times 180 over 4. And let's use the calculator for that, because you're allowed to calculate. So 180 times 17 divided by 4. 765 degrees. Perfect. Now, obviously, I am going multiple times. Once 360, second time 720, right? And now I have minus 720. I have 45 degrees. So I am right here. This is my reference angle, 45 degrees. Okay, it's on the first quadrant. So secant of, but it's negative, right? So I'm going the other way. So be very careful. So I'm going this way. So first revolution, second revolution, and here is my pi over 4, right? I'm sorry, 45 degrees, which is pi over 4. So I am right here. So secant of minus 17 pi over 4 is equal to, and I'm going to use the thing in terms of the reference angle, okay? It's equal to secant of negative pi over 4. Now, we don't really like to work with secant, so we use the reciprocal. So 1 over cosine negative pi over 4. Now, cosine of pi over 4, negative pi over 4, is the same as cosine of pi over 4, 45 degrees, because cosine is the x-axis. So this expression here is 1 over cosine of pi over 4. I'm sorry, I should be using the 45 degrees, right? So you can change this, everything here, to 45 degrees because we were using degrees anyway. So secant 45, cosecant negative 45. And from here to here, we realize that cosine of negative 45 is exactly cosine of 45. And I'm going to show you that in a minute. So cosine of 45, I already know, radical 2 over 2. So multiply by the reciprocal, we get 2 over radical 2, rationalize, and we are going to get 2 radical 2 over 2, which is radical 2. Now, I am going to show you that. So this is my answer, and it's correct. I am going to show you what the important thing here that you must know, that this, okay, or that cosine of negative 45 degrees is equal to cosine of 45 degrees. So this is very important, and you must know that, okay? Or what you do is what I did before, right? You pick an angle in the fourth quadrant to see if your cosine is positive or negative. Now, I'm going to use the calculator now, and you can do the same, or you can do it logically the way I did. So first, let's find cosine of 45 degrees. So 45 cosine, 0.707. And let's do 45 negative and cosine. And the answer should be positive 0.707. And here it is, positive answer 0.707. So this is true. Cosine of negative 45 is equal cosine of 45. So you need to know that. If you don't know that, then you can pick an angle, like I said, in the fourth quadrant and confirm these two facts. Okay? In this case, the answer is radical 2. So in this section, we need to be able to, number one, find the reference angle, and then number two, know or be able to find with the calculator if the trig function of a particular degree angle that we have, or radian, is positive or negative in that particular quadrant, to find out if the function I need to evaluate is going to be positive or negative. Okay, so this is how we use reference angles to evaluate these trigonometric functions.